Well, I want to thank you for being here today. Thamban Meloth is the director of the National Center for Polar and Ocean Research of India. And he's giving a talk today on melting glaciers and its impact on hydrology and hazards in the Himalayas. Thank you so much.
Thank you, Megan, and thank you, Click, for giving me this opportunity to interact with the glaciological as well as cryosphere community to talk the perspective from the tropical world. So today's my lecture is titled as Melting Glaciers and its Impact on the Hydrology and Hazards in the Himalayas. And I belong to the National Center for Polar and Ocean Research, where we work more not only in Antarctic and Arctic, but also on the third pole, that is the Himalayas and its various hydrological impacts. So if you look at the polar cryosphere itself, so you can see that, basically we deal with mostly ice, glaciers, or the ice sheets, as well as the sea ice, that is in Antarctica, as well as in Arctic. And if it's Antarctica, it's mostly the what you call the land ice, which is the most dominant feature. It is when you go to Arctic, it's mostly the sea ice, the multi-level sea ice, multi-year sea ice, that is the most important. Of course, there is also the Greenland, other small islands around there. However, if you look at the difference between the polar as well as the high mountain cryosphere is that if you look at mainly the ice sheet and sea ice is the dominant features in the polar regions. When it comes to the mountain, cryosphere, it's the glaciers, most of them valley glaciers, and then you have the permafrost, permanently the frozen land, and also some cases you have an ice cap over this high mountains, and then you have this snow is one of the dominant feature in this high mountain cryosphere. Then you have various associated features like this formation of this proglacial as well as supraglacial lakes, and the associated various features and factors which make the high mountain regions highly complicated and complex feature by itself. So if you look at the changing the warming climate, what is brought to the mountains is that actually the loss of glaciers. Especially since the nearly last 4 decades, you can see a very strong signal of loss of the mountain glaciers, as you can see from the World Glacier Monitoring Service. There's a consistent decrease, happening since the last several decades, which is a very clear indication. Actually, the global warming is really impacting the mountain glaciers much more than the rest of the many other places. If you look at what we understand currently on the current how the cryosphere is going to behave in future, it is something we have a lot of information already, especially after the IPCC reports are come. Even before that, actually, there's a special report on the ocean and the cryosphere on a climate changing climate has come, and all this has provided us some kind of information actually that the snow-covered glaciers and permafrost are projected to continue to decline almost all regions throughout the 21st century. And especially the cryosphere hazards are projected to change in frequency, magnitude, and the areas affected as the cryosphere continues to decline. And runoff from the snow and glacier-fed river basins will change further in amount and seasonality, with the negative impacts on agriculture, hydropower, the generation, as well as the water quality in some regions. The current trends in cryosphere-related changes in high mountain ecosystems are expected to continue and the impact to intensify. This is something which we already have quite well versed in understanding. If you look at the mountain cryosphere itself, if you look at all over the world, the dominant thing what you see in the high mountain, the Asia, then you have this South American the glaciers on the high mountains. Then you have this frozen land over the northern, the Europe, especially the Eurasian region. Of course, then you also have some of this, mountain glaciers in some of the northern hemisphere also. But if you look at this, actually, the most dominant and most largest change, what we have seen is actually in the high mountain Asia, as you can see in this part of the world, which is actually have a very large population also, depending on that. So if you look at the Hindu Kush Himalaya itself, both the ice volume and whatever the changes happening are more significant. Nearly about 50% of that high mountain Asian changes actually are found in Hindu Kush Himalaya. Most importantly, the Himalaya and the Karakoram region. And the climate system itself is actually quite different in the entire Himalayan as well as Karakoram region. If it's the westerlies dominate the Karakoram region as well as the Western Himalayas, which brings in the Western the precipitation in the form of Western disturbances, especially during the winter time. When it comes to the Himalayan region, it's mostly the Indian monsoons, which brings in the precipitation, the moisture during the summer period. And therefore, you also find the glacier distribution as accordingly varies from place to place along the Himalayas and Karakoram. The largest thickness of the glacier volume are found in the Karakoram as well as the Western Himalayan region. And as you go to the Eastern Himalaya, they significantly decrease because also there is a large impact of the monsoon in that particular region. If you look at the impact on the population from this figure, you can also make out that the largest population also lives around this particular the cryospheric regions. So as you can see, the red color all along this Indian subcontinent as well as the other Asian region, there is a large amount of population which directly or indirectly depend on these cryosphere. So even if you look at the major glacio-hydrological regimes of this, the Himalayan Karakoram also, you'll find these large differences when you go from the west to the east. If it is mostly the glacier dominant melt is the most contributing to the glaciology or the hydrology as well as the water balance of this, the downstreams in the Indus basins and as well as in Tarim basin here. Then, whereas when it goes to the Ganges basin as well as the Brahmaputra basin, there's also a significant impact of the Indian monsoons keep coming in. And in some of the the regions actually it's the monsoons which are the most dominant contributor. That's the rain is the most dominant contributor to the river basins along the eastern the part of the Indian subcontinent. So even if you look at the glacier cover, when you look from the Karakoram regions to the eastern Himalaya, there is a very high cover along the Karakoram regions. When it goes to the eastern Himalaya, you find a significant decrease in the glacier cover. This also has to do with the kind of the climate system existing, which is one is monsoon dominant and the other one is actually westerly dominant. So what are the main importance of Himalayan cryosphere? If you look at it, they are very key for the sustainability of the region, the economy of the region, and the energy needs of entire South Asia. Because the more and more as we are looking for the carbon-free energy supply, there is a large focus on this hydropower electricity in this part of the world, which is also increasing the impact or increasing the load on the Himalayan, the Karakoram cryosphere region. Because they also feeds to 10 major river systems in the world, that supports nearly about 2 billion people directly or indirectly. They plays a vital role in the global weather and climate, and most importantly, the Asian monsoon system. And towing Himalaya has a very strong impact on the downstream environment, water availability, human health, and sustainable development of South Asia and its people. The defrosting of Himalayas also impact the stability of slopes, the increased incidence of floods due to the glacial lake outburst or rain on snow, landslides, and slow avalanches. One of the most important also, the critical factor is also there is a serious deterioration happening in the Himalayan environment and its ecology. These are major concerns again. If you look at the Himalayan cryospheric system itself, compared to the other alpine systems and all, you have the various other features like this, happening with typically what you find in the alpine region. Actually, there is a snow precipitation, there is an accumulation zone, there is the ablation zone of these glaciers, and there is a strong avalanches happen in the high mountain areas. But when you come to the high mountain Asia glaciers, actually, you also find a large, cover of debris over the glaciers. Many of the glaciers in the Himalayan region are covered with the debris, which also impacts its, what you call its health in terms of actually how much glacier could be losing mass, because if it is the debris is very slightly, very little, then there could be enhancing the melting, whereas the glacier debris cover is too much, very thick, then you really don't, they save many of those glaciers. And most importantly, you find most of this, these such valley glaciers in the Himalayas also terminating over a lake. And these lakes, first they occupy actually as a glacier retreat, and they keep expanding as the glacier retreating further, which is also becoming a major hazards in this region. That's why you find in the floodplains of this the Himalayan cryospheric region also are highly populated. You have various what you call construction, other things already existing, and it's rapidly growing. So all this makes the Himalayan cryospheric region slightly different from the rest of the world. And if you look at the mass balance change itself in the Himalaya, and it's changes since at least since last nearly 2 decades, where you have a very strong data exist. You find a very distinct 2 features. One is in the Karakoram region, where there's a mass gain, and then there is this the central as well as the eastern, the western and the central Himalaya, where you have the very significant loss of the glaciers mass. And this also has to do with as I said, actually also the climatic feature as one of the reason actually, as well as the various other factors are involved too. So if you, I also want to just give a glimpse of the kind of the case studies which we also carry out in some of this major basin in this part of the world. And in this case, actually, I focus on the upper Indus Basin. It's what we call as the Chandra Basin, which is quite, if you can see actually that this is this part of the Western Himalayan region, where it's in the transition zone of an arid cold region. From the central Himalaya, where you have this what you call the cold and as well as the monsoon-fed glaciers over here. The Chandra Basin itself is actually about nearly 2,500 square kilometers, quite a large sub-basin, which are having several large numbers of glaciers, including a very large glacier like Barasagiri, which is actually nearly about 130 square kilometer area. So we have been focusing on this particular basin for quite some time now, with a lot of studies going on in the glaciers, as well as the downstream, the hydrometeorological factors, like setting up various several AW systems and the several water level recorders to understand how much these glaciers are changing, how much they contribute to the water in the downstream, and what are the basic, the hydrometeorological factors governing this, their health and the future. As you can see, actually, that for the nearly last 2 decades of data very clearly shows that there is a significant loss of glacier mass. In some cases, as much as nearly 1 meter loss of ice every year happening in some cases, and some of them actually, on an average, nearly about 50, nearly half a meter of the ice is being lost every year. And if you look at compare with the field measured data with that actually of the model based output using which is basically also calibrated and validated with the available a lot of data which are available in this particular basin, which very clearly shows that the models, especially the physically based energy balance models, very clearly are able to replicate what the field based data, which has been generated after several years, nearly about nearly about 10 years of data, which clearly are supporting that actually it is possible to use these models to efficiently to identify a distributed mass balance across the basin, as well as to use them for a future prediction as how will they will be responding to the future changes. So the sensitivity of these glaciers also been studied, and they find that actually that there is a clear sensitivity towards the temperature and precipitation, and even the ongoing study very clearly says that actually the temperature sensitivity is very high, and the entire basin study clearly reveals that nearly about a 42% of increase of precipitation would be required to compensate even an additional mass loss to the 1 degree Celsius increase in the air temperature. That shows the temperature is really one which is governing this region, and even if there's a significant amount of increase in precipitation as the global, the warming is taking place, it may not be able to compensate what is being lost because of the changes in temperature. And if you look at the hydrological impact of this waning cryosphere is also, if you look at based on the projected, the peak water conditions has been, earlier studied by Matthias Huss and Regina Hock, and as well as recent studies, for the entire across the region. There's a clear two, regimes you can find along the western, the Himalaya as well as central Himalaya. And you have a significant, what you call the peak water reaching as early as in 2000 in another decade or so in the Western Himalaya, whereas it could be much further delayed actually along the central and as well as the Eastern Himalaya, of course, and also in the Karakoram regions. So this is something actually we find there is a regional heterogeneity across the region. And the expected runoff changes under such climate changes also will have an impact, not only the total meltwater from these glaciers, but also it will impact the seasonality of the water availability. Of course, you will have the impact of actually that once you have a peak water is reaching, there will be significant decrease after that, towards the end of the century. But more importantly, as the glaciers are decreasing, you will also find that the water flow peak also will shift towards more from the summer, where you have the normally typically glacier meltwater used to happen, to more of the spring, where mostly it's the snow meltwater will be happening. So there will be a significant difference in the kind of water availability, because in most of the Himalayan, the downstream region, when the real water requirement happens during the summertime, peak summer, when there is very little water available. But unfortunately, that may not happen, as if you have the glaciers are lost and only the snow is going to contribute to the hydrological system. So this is another case study actually looking at the sensitivity of different contrasting basins, different contrasting climate system. One is in the Western Himalaya with a very, what you call the mostly winter snow dominated basin. In this case is the Chandra basin. And then also you have this summer rain dominated basin along in the central Himalaya. In this case, it is upper Dudhkoshi basin, part of the Ganges basin catchment. So the one thing which very clearly identify, and this particular model using the VIC model, using the calibrated again with the data from both the basins available. The summer runoff from the glaciarized parts of both the catchment is found to be more sensitive to temperature changes, whereas it's relatively insensitive to precipitation changes. However, in case of the non-glaciarized parts of this basin, it's other way around. The summer runoff is basically it's exactly basically sensitive to more precipitation and less sensitive to temperature changes. And they also find that after the peak water, which is could be happening around 2030 or so, the summer runoff is going to expect to become more sensitive to precipitation forcing in these catchments. Then the temperature may not be that much important, because by the time the glaciers are lost, you only have snow. So therefore, actually, it becomes more the precipitation decides the kind of the hydrology of the catchment. However, there are various challenges on estimation of hydrological impact of Himalayan glaciers. The accurate estimate of any glacier stored water in Himalayas itself is a grand challenge for quantifying, basically because there is no proper data exists on ice thickness on glaciers across the Himalaya. Because most hydrological impact studies use model ice thickness data using various methods with extremely high uncertainty. Sometimes, some cases, there are several orders of differences, because there's hardly any ice thickness data available other than very few point measurements in some that to very limited few glaciers. So the Himalayan glaciers are the main reason for that is actually it's also that the glaciers in Himalaya, especially high Himalayas, are highly challenging for field service, and they're mostly wet. They are very temperate in nature. They are highly debris covered, and also with the extensive subglacial water channels. All this makes extremely challenging for a typical, ice radar based, the thickness measurements. Therefore, it is important to also develop innovative airborne radar systems operating at very low frequencies in order to overcome those scattering and losses. There's some work is going on in this direction actually to have finding potential solutions to this. Another thing which happened actually during this IPCC reports were coming, at the same time, the Ministry of Earth Sciences in India also came up with an assessment of the climate change happening over this region, which gives although it is basically report is about the Indian region, but it also covers the entire the Himalayan region. And they see that actually there is an annual mean surface temperature in this particular Hindu Kush Himalaya increased at the rate of nearly 0.1 degrees Celsius per decade in the nearly almost a century. But then it's it's almost doubled during the last nearly about 50 years, which has been attributed to the anthropogenic climate change. And even the future climate projections under various CBIP 5 scenarios, the multimodal ensembles clearly suggest warming of this Himalayan region at nearly about 2.6 to 4.56 degrees Celsius by end of 21st century. And the future projection also clearly indicate a significant decrease in snowfall in several parts of this region. And if the projected changes in the Himalayan Karakoram region also indicate a tendency for extreme warm days and extreme cold nights to shift to actually more warmer in the future. And the future the projected changes in precipitation extremes, which is basically, when you call extreme, actually, in this case, they look at the exceeding the 95th percentile. That's the terminology. How do they use it? They also find a significant increases in both this RCP 4.5 as well as 8.5 scenarios, which indicates a clear increase in occurrence of extreme precipitation over Himalayas, especially in the central Himalayas. So central Himalaya is the place where it is very, which is going to harm much more, because that's also a region which is the mostly, very highly populated, the population living and close to this mountain region. So if you look at the future projection, you can very clearly see there is with various RCP projections using various multi-ensemble models, very clearly show there is a significant increase in surface air temperature on an annual as well as even during winter time. So the winter time is extremely important, because that's actually when you typically are expecting preserving the snow which is falling, and that's not a good sign. And precipitation could be increasing in many cases, but the snow itself, the precipitation could be mostly, it's more of rain, in the form of rain, not as snow. Because if you look at the rain in the projection, it looks very negative, but the precipitation itself is increasing, which is clearly a bad sign for the Himalayan, the glaciers, because you have a potential increase in the impact of rain is reaching higher altitudes, and the snow is decreasing, which will not be, very useful for the protection of this region. And as an impact of this changing climate, the hazards related to cryosphere are basically snowballing into the Himalayan Karakoram region. You have already a snow droughts in many high mountain peaks. You can also have sometimes extreme snowfall. And then because of this, thawing of permafrost, there is a permafrost instability happens, which lead to, things like avalanches occurring, and even hanging glaciers, which, which finally they lose their, ability to hold. And these glaciers also are detaching in some of the valleys, which are already, there is a lakes existing, which are constantly expand, and also in extreme cases, they lead to a gulf. And there's been already very clearly seeing in Himalaya, year after year, we see a very large events taking place, for the last several tens of years now. One of the classic examples which has happened in the Kedarnath disaster in 2013, which was essentially related to an extreme weather event, which is happening around the glacial lake region, and the lake is unable to withstand the kind of the ferocity, and ultimately losing its ability to withstand, and finally devastating the entire nearly about 4,500 villages in the downstream, losing more than about 6,000 human lives. And these are actually increasing every year. And for example, in another example is actually of the Chamauli disaster in the northern India, in the Uttarakhand the state in 2021, which was related to rock and ice avalanche. As I said, actually, that it's the ability to withhold many of this the hanging glaciers or this the rocks which are basically earlier frozen to the ground are now losing their ability to stand together, so losing its mass. So such things have been, and again, this was a huge disaster which killed nearly about 200 people and even damaged a major hydropower project. And of course, damaging several bridges, roads, and it's affected the entire stability of the region. And even some of the studies indicate that as a potentially a retreat of glaciers can also, in high mountain glacier could also be associated with more and more frequent landslides. This is one of its kind of study actually, but several more studies required to confirm this. However, what is very clear is that the melting glaciers do create lakes. In most cases, they are proglacial lakes, which are the lakes in the front of the glaciers. And as the glaciers are retreating, these lakes keep expanding, which leads to potential cases actually where the possibility of a glacial lake outburst flood, because these lakes are essentially just moraine dammed, which are very vulnerable to any topping, but also sometimes also breaching, because in many cases they can, sometimes it could be a simple carving of this the glacier front, but it could also be sometimes a cloudburst or the extreme rainfall happening or the such things happening there. So these expanding glacial lakes are very potential hazards in this region, because Himalayas host more than 5,000 glacial lakes, most of which are proglacial in nature. And studies clearly shows that such lakes have increased nearly about 50% by number, 30% by area, and 40% by volume from the last 20 years. And some of the most rapid lake expansions found in central Himalayas. This is a bad sign because this is also, as I mentioned earlier, where the downstream areas are also heavily populated and quite vulnerable, and making the region very highly vulnerable for the GLOF situations. And importantly, the studies also indicated that there could be significant mass loss underestimation itself. What we know is only could be a tip of the iceberg, because one of the recent studies indicates that actually there could be a significant underestimation in the mass loss in the lake termination glaciers, basically because of the poor constraints on the subaqueous the mass loss, because most of the time we use actually the kind of satellite data which does not give you an information about what is there below the water. So the geodetic data which uses typically to measure the glacier mass loss could be underestimating by nearly about in some cases as high as 10%, which could be very significant amount of the glacier mass, which is in this case about nearly the 3 gigatons of glacier mass, which could be underestimating in this. And this underestimation is very significant in case of central Himalayan and partly in the eastern Himalayan. So this is something which actually, again, we need to consider when we think about actually what is being, being lost, and as well as what it could be leading to the kind of disasters. This is another, the study which by Ni et al, which shows that, this is a very significant relationship between the lakes existing, which are those blue dots you find all throughout. As I mentioned, there are nearly more than 5,000 of such lakes. And many of these lakes are, as I mentioned, they are expanding, and they are a potential GLOF. In fact, there are already several reported GLOFs in this all this region. And especially in the eastern Himalaya, you find they are continuously being, these GLOF events have been becoming larger and bigger events. And one of the very classic case was a very recent, which happened in 2023 in South Lonak, the GLOF event, which, which is again actually, which was being predicted for quite a long time. But, nothing could be actually done because of the various reasons. So the various, in this case also, again, we lost, hydropower, the project. So several hydropower projects do exist in this, along this region. And they are continuously increasing because there is a large amount of potential projects, ability to get harness the, these rivers for power requirements of the growing population. But it also have its own environmental, reasons, impacts going to happen. For example, this in case of South, the South Lonak Lake, the blow-off which happened in 2023 in Sikkim region of the Indian, part of which is part of the India. There is a very clear case actually, which has been waiting almost for a decade, because there are several studies which, way back in 2013 very clearly indicated there is a potential this lake could be breaching. And as very recently in 2021, which is even quantified the potential losses as well as the impact in the downstream region by in Sattar et al. Actually, the study very clearly gave the very detailed, how it could be impacting. And even the National Disaster Management Authority of India, what we call as NDMA, also made several surveys and initiatives based on this, these projections, how to mitigate the potential growths. In fact, they tried, we can see in this case actually, several yaks carrying, for this, these large pipes. They were looking at trying to siphon out the lake water. They leaked the water in a way that actually could may at least control it. And then they also initiated a potential early warning system in this region. In fact, just a couple of weeks before the actual blow-off event happened, there was a team, undertaking the setting up various instruments in this particular region. But unfortunately, this blow-off did not wait for anyone. So this is a classic case where we know there is a potential, blow-off could happen and could be seriously large enough. But however, the terrain is so remote, terrain is so difficult to approach in many cases. The potential of implementing an early warning system is becoming extremely very challenging. So this is only one such cases. As I mentioned, there are nearly about 5,000 such lakes. So even if you want to put up an early warning system, how many such lakes you can do it? How much effective it could be? These are the questions which are still need to be answered. Only till we find such real solutions to it, the only way is actually the systematic monitoring of such lakes. In this case, it's my own colleagues carrying out studies in this Chandra Basin, again a large lake which is been expanding very dramatically for the last few decades. So the bridging the gap between the research and services is going to be the most important thing. Because considering such a large regional as well as site-specific nature of extreme weather events and associated geohazards like blow-off, avalanches, landslides, flash floods, all this happening in this in high mountain Himalaya, a combination of in situ as well as high resolution, focused high resolution satellite data is required, with a combination and support of a very efficient modeling system. You may be at least able to know actually what are the potential impact. However, unless until you are able to put up any of such current and emerging risk in this region also require a research to services approach. Unless until you are able to do that by filling the gaps to the real, it's one thing about understanding a process, understanding what you call an impact. The other thing actually about giving a real-time data for forecasting what could happen. So research to services is something actually it's at infancy. In fact, the most part of the high mountain, the glaciers, and that's something which this is the gap which needs to be filled, and the partnerships as well as regional collaboration would be key in this particular process. So in fact, the WCRP CLIC itself is coming up with a mountain cryosphere planning group, which could be a very great way to great way forward in this particular aspect. When WMO has been first of this particular issue, which has come up with a panel on high polar and high mountain observation research and services, what we call as FORCE, which aims to bring awareness as well as bringing partnerships to enable the member countries to potentially with a uniformed and as well as in a very very efficient way of addressing these issues. So to summarize, we know that actually Himalayan cryosphere is threatened by a changing climate, with most glaciers losing mass, except probably in Karakoram region. And it's highly heterogeneous also in nature across the Himalaya. That's something which you have to keep in mind when we are dealing with Himalaya. And the cryosphere change directly affects the river runoff, Consequently, the composition and seasonal variability of the downstream river flows. An accurate estimate of glacier stored water in Himalaya itself is a grand challenge for quantifying its societal impact. Due to, as I mentioned, due to the fact that actually there is hardly any real data existing on the thickness of the ice sheets in this region. And defrosting of Himalaya in a warming climate has a significant impact on its sustainability and safety of its environment, with increase in magnitude and frequency of hazards happening. And emerging risks in high mountains require a research service approach by filling the gaps to emerging information needs of this society affected by especially by those changes happening in the cryosphere. Thank you so much. That's all from me at the moment.
Oh, thank you so much. That was really interesting. And I'm wondering if we can open it up to questions. We've got time to take some. Yeah, Keith.
Thank you, Thamban. That was a really interesting talk. I actually have two questions. The first one is about response to events. And I draw on the horrible earthquake that just happened in Taiwan, greater than 7 order magnitude, but with relatively limited devastation. And I say relatively. Obviously, people died and there were catastrophic events. But two of the things that are cited for relatively less than that might have occurred otherwise, one was there was a little bit of warning. Just a few seconds is enough for people to take cover. And so in the case of these GLOFs, I'm wondering if even a little bit of warning, perhaps derived from satellite and real-time data, can be useful, even if it's only seconds to minutes. And the second thing that's cited in the Taiwan case is the building codes. A lot of the buildings are built to withstand earthquakes. And whether building hydropower, for example, to be able to withstand sudden GLOFs is feasible or not, or at least to think about that in advance. So that's my first question. My second question, you mentioned the change in runoff shifting from summer now more towards spring. I think that's almost certainly true. But another possible change would be, and it's obviously locally dependent, shorter periods of runoff. The glacial runoff would be over a long period of time over the summer, to shorter and more intense runoff since it's rain rather than melt. So those are my two questions. Thank you very much for the very informative talk.
Yeah, thank you, Keith. I think you raised the very relevant questions. In fact, that's something actually the early warning system is something actually, even if it is actually, as you mentioned, actually, even if it's a very short time, it could be still valuable. For example, but however, in case of mountains, actually, what you can also keep in mind, that when you say short period, actually, you would require at least an half an hour in advance, actually, because of the kind of the terrain and the kind of this, the villages situated are in such places are require at least a slightly longer, time period. But even then, a warning system could be of use. It's only a matter of probably the time actually that now you are in the grip of actually the situation. People know that actually this is going to happen. This is something which is going to happen. Now, what is the best way forward? The combination of very real-time satellite data, or real-time the systems actually various automated instrumentation systems, which is actually practically working in the cases of Alps, for example. But in high mountain places, it has not been very successful till now. But I think there are cases actually which has worked in some cases. So it could be. I think we are in the early stages of that. Real coming up with with the getting absorbed of this particular issue. I think there is going to be a potentially large improvement in coming years, because it's situation is so very complicated at the moment. So everybody is understand that something need to be done. As far as what you consider the second one, actually, of course, I think what you're saying is very clear, because as it's not only just the shifting towards this springtime because of this snow melt could be a very very short period of this snow melt happening. but also this the rain on snow as well as the rainfall itself increasing, because as the study clearly shows there could be a precipitation increase, and that could be very what you call again. It will be very, I think, will complicate the situation existing, because it would again will be short. That these are all flash floods. Many of them actually, when it happens in the high mountain Himalayas, they happen as a flash floods, which actually impacts quite a lot of even the downstream, the projects like hydropower, generating systems and so many things, and the villages and so on. So these are actually, I would say, actually again are something which we need to be need to be more prepared of. Actually, how do we project it in coming years? How do we make it more of a sustainable way of living in this region? Thank you so much again, Kate.
Christian has a question he'd like to ask.
Thank you, Dr. Thamban. Can you hear me?
Yes.
I really enjoyed your talk. Thank you so much. It was an excellent talk. I have two questions. You were mentioning that more number of glacier lakes are forming and there is an assessment. So is it possible to have some kind of a risk assessment of due to the formation of the glacier lakes? That information, if it is there, then probably it will be good to have some kind of a risk assessment so that people can be prepared, or this will be useful for the policy makers to take certain decisions.
Absolutely. I think this is something which has been happening actually, especially the national disaster management, the authorities already has formed a large team of people actually, including scientists and people who are able to the disaster management people, as well as the scientists and the few people who can come up with kind of solutions. So this is something has been already there's a large documentation thing is being happening now. Now from the documents to make it a real time is one thing which is actually a bit challenging, because I think by the time NDMA was coming up, for example, for this particular lake, things just went out of hand, because it is so slow in those regions to set up anything, that speed is something which will require, I think, new technologies. I think the technology improvements need to be, make it, much more reliable and useful.
Okay. And I have one last question. In 2022, there was this big flooding in Pakistan because of the runoff and also rainfall. I also understand that during the pre-monsoon time, there's a lot of heat in that region, in the upper Indus Basin, and glaciers had melted. And this was a big La Nina in the Pacific. And also 2010 also, there was a big flooding in Pakistan. But 2022 was devastating. And both these periods, it was a La Nina and monsoon was strong. But also now with climate change, the glaciers are melting. So I think if we can have with all this information, it may be possible to have early warning system. I think Peter Webster wrote a paper that we may be able to predict this heavy rainfall in that region.
Absolutely.
And,
that's what I think we look forward to it, in fact.
Yeah, and at least 1 or 2 weeks in advance. And if we have the information about glacial melt also, then maybe we will be able to come out with some estimates of flooding and runoff.
Yeah, at least, if you have a regional, at least some basins, at least some of them, at least if you all of this, you can't put up an early warning system, but at least focus on some of the sectors which are going to be really vulnerable kind of thing. I think that will provide a lot of confidence to the system, and then probably in future you can take it forward.
Yeah.
Thank you.
Yeah. Thank you very much.
Tom, we have a question in the comments. Kate wanted to know about the agricultural season. With melt season occurring earlier in spring, are we able to quantify how much this might impact agriculture? Is it hard to quantify because of the uncertainty of the size of the glaciers?
Yeah, okay. I think, okay. You were talking about, curious about the agriculture season. Actually, yeah, that's something actually going to be shifting again, because that's something I think, adaptation is something is going to probably may make difference. How do people, the agriculture season actually itself actually you shift depending on the kind of water availability. And this is something which is the studies in fact do happen. Actually, I think I can make out actually there are people in this particular group itself actually will study something on the climate, the impact of climate on the agriculture and all in this region. So there are people who are better, placed to answer this question. Thank you so much.
Anyone else have a question? Okay, with that, I'm gonna thank you so much.
Thank you so much, Megan, and thank you so much, Click and all the, the members of Click SST for, I can see a lot of people attending, and thank you so much to all of you.
Okay,
Thank you.
take care.
Bye.